Hello everyone, welcome to the Rhino Architecture Online School. Today, I will talk about the modeling method of this phantom. Because each member of this phantom is different, we need to give it a number after we finish the model and cut the material to produce the process and drawing. Okay, let's talk about modeling today. First, you can open the new case of building curtain wall aluminum plate data. Our first case is such a cell, and then you can open this Rhino file. Let's first look at the results we need to do. Let's analyze how this model is made. First, let's take a look at how the modeling idea is explained. I have written the modeling idea here, which is that for any model we get, its idea is just a few sentences. So how should we interpret this idea? He said that complex models are multiple surfaces composed of multiple single surfaces, and you need to learn how to disassemble them. Then let's take a look at this. We think of it as a surface composed of several surfaces. According to the usual analysis, it should be a multiple surface composed of three surfaces, upper, middle, and lower. Therefore, you need to break it down into three parts to make it. Then break down the multiple surfaces into a single surface and see if these single surfaces are made with a layer track, a second track, rotation, or a mesh interface. So let's take a look at which command was used to make this surface. Actually, for this surface, we can draw a straight line, then draw a curve for transformation, and then draw two curves in the middle with a section in the middle. This is enough. Below the second track is also a curve, a straight line. By changing the sample, we can obtain this surface. After obtaining this surface, we make some equidistant cross-sectional lines for it, squeeze out a certain thickness, and then we hollow it out from here. This is roughly the shape we obtained. Okay, let's take a look at the production process of this. First, we need to draw a surface. I put it next to it. We draw a plane, mark it with a 0, and give it a length and width starting from the origin. You can input a length and width. Then we need to draw this shape a little bit. It looks like this. With slightly fewer chance points, the smoother it will be. If you are not satisfied with the shape, you can adjust the control points to get the shape you want. Then we use this to trim. First, select the line, then select the object to be trimmed and click on it. At this time, you can use the rendering mode. If you use the line loop mode, you may need to click on this structural line to click and then delete it. Then we add a line to it because we need to capture the endpoint object in this section. Yesterday, we opened the endpoint and rebuilt it. Rebuild. What level of reconstruction? What time? Level 3. How many points? Okay, 6 points. Why 6 points? Shall we open the point? We slightly pull out this shape by opening the operating axis. Then we can make these 2 points tangent downwards like this. You don't need to do this, just return the pointed Ctrl Z. Then we leave the control points to shape this shape. You can distribute these 2 control points a bit, so it will be easier to do 6 points. This shape. Okay, after finishing, we can use the double track, with 2 tracks and 1 cross-section. The first path of the double track selects the path, and then selects the cross-section line, which is tangent because it is tangent here. After confirming, you will find that it will be smoother, and you will get such a shape. I just mentioned that I used lofting to make this surface, so you need to draw these 2 lines, right? Using dialects to obtain this exemption is the same principle as using Shujian. Okay, after obtaining this shape, we delete the lines, select all the lines in the selection, and delete them with delete. There is no rendering mode. I set the rendering mode of Rhino 6. If you want to set it up, you can click on this display view display mode rendering, and then you can use this default lighting, which looks a bit like Rhino 5. Then if you don't set it, it's a bit like this polar mode, it's this effect. Okay, then we will select the equidistant and boundary line for it. We need to establish a physical selection of the gridded and boundary line. And then look at the reference point of the line plane of the equidistant section line of the carriage return. We can grasp the endpoint, and then the direction perpendicular to the plane of the equidistant and boundary line is the vertical direction. The direction perpendicular to it is of course the horizontal direction. Then, you can check the spacing setting. Currently, this grid is 1 mm, and you can choose 0.4. Then got a lot of these poles. Let's set it up again, a little wider 0.6. Then I pull it over, and after getting these lines, I give it an extrusion, and then the extrusion distance is greater than 0.6 smaller 0.4. Then we get this surface, and then we get this surface, which is a multiple surface. When you blow it up, it becomes a single surface, right? Do we need to explode it? Let's take a look. We will use this to extrude curved surfaces. You will find that when you choose, you will find that it can only extrude these few. Why? Because this is a multiple surface. It is not a curved surface, so you need to explode it into a curved surface in order to use extruded surfaces. Then click in the wrong direction. Then the first point, the second point, hold down Shift to lock this direction, and give it a thickness, for example, input 9. Then these need to be deleted here. Then we use rendering mode to look at its results, and then we make the shape. If you want to make the shape flat at the back, you can squeeze out a little thicker, and we can cut it flat. How to switch the screen? We cut to the top view, and then we can draw a line like this, which can directly trim this width in the top view. After selecting it, we successfully trimmed it. Then we looked at the back and found that it was empty and not covered. Then you will find that it was extruded and divided into 3 parts. Do you see? It is 3 boxes. What if you need to turn it into 1 box? We can blow it up and delete the middle parts. So is there a quick way? Also, let's first hide what we need. These 2 sides are needed, and then this one should also be hidden. Then we select this one from bottom to top, pull it over like this, and if we touch it, we can select hide. If we don't touch it, we can't select it. We select hide from bottom to top like this. Then he will leave the upper and lower covers. Then we don't want these, because there are 2 more here, see? So we delete these, right-click to display them, and then we combine them. Then it was done one by one like this, and then we finally added a cover to it, covering the plain hole, and then it went crazy. Okay, you will find that there is no cover inside. Why is that? This is because we accidentally deleted the following. So what should we do if we delete them? We can use lofting to patch up this surface, then combine them all, and then cover it. Okay, everything is done in this way. After the model is built, we need to number it and generate processing drawings. We have a similar case. Of course, you can refer to this document 6. Then there are curtain wall segmentation numbers to generate processing drawings. So you have these courseware, many of which you can use. Okay, in the next class, I will teach you how to number and cut materials to produce processing drawings.